I give you another example, and that's we are having here the different from the first one. We're given here we want to find the general solution of the differential equation x square y double dash minus 3y is equal to 6x to the power 4. By method of reduction of order, we're given here the solution y1 is given to us, that is y1 is equal to x square, and we want to find the solution of the homogeneous. But now here we can see this is non-homogeneous. When you take this equal to 0, this equation is homogeneous because y equal to 0 is solution of this one. The homogeneous solution is where y is appearing in either all of the term is homogeneous. I will say when y equal to 0 is the solution is a homogeneous one. And then here we having the equation is f of x. Due to this one, this become non-homogeneous. But the method is same for both of them. Here what the first step, we take y2 is equal to u1 of x, reduce it to the first order by substituting w is equal to du by dx. Same is here. We take u2 is equal to uy1, and then we take du by dx is equal to w, and d2 by dx is equal to dw by dx to reduce it to the first order differential equation, and then we solve it. Here I can see we can just go ahead like this one and see how we can find our solution. So first we substitute the solution of just step 1. Our step 1 is the y2, that's our y, is equal to uy1. Our y1 is x square. We find here y dash. Y dash is derivative, this one is u, the x square is 2x. Then here du by dx for derivative of x, u and the x square. Then y double dash. By y double dash, we get here this is 2. When we take the derivative of u, or derivative of x is 2u, then 2u derivative of 2x, then derivative of u is du by dx. Here I take this term, I take derivative of x square, I get here 2x du by dx, and then we take derivative here du by dx, we get here x square d2u by dx square. So this is my derivatives. I substitute in my differential equation, I multiply y double dash by x square, and then combine these two terms also. We get it for it. Multiply by x square, I take this one here, x to the power 4, x to the power 4 d2 u by dx square. Here is x square. Multiply by x square, what I will get here 4 plus 4x to the power 3 du by dx. I multiply by x square. Then here plus 2x square u. So this I have x square y double dash minus 2y. Multiplied by 2, we get here minus 2u x square is equal to the right hand side. My right hand is 6x to the power 5. Now I simplify, as I told you, we must have this cancellation, and this being cancelled here. You can see here minus 2ux square and minus 2ux square, they are cancelled, and we'll get here the differential equation after the cancellation. We get here x to the power 4, get here d2u by dx square, then plus 4x cube du by dx, and this is equal to 6x to the power 5. So this is my new equation. So as I told, this is my step 1, that I reduce it to this form. And here what I have to do is substitution. I substitute du by dx is equal to w, and d2u by dx square is equal to dw by dx. So this is what I want to substitute here in this equation. I substitute in this equation, what I will get? I get here x to the power 4 into dw by dx. I said replace d2u by dx square. Then plus here I'll just change it. This here, and then I just change du by dx by w. We get 4x cube w is equal to, we have the left hand side, right hand side 6x to the power 4, 5. I divide by x to the power 4, I'll get here the equation as dw by dx plus 4 upon x w is equal to 6x. So this equation I'll get here in my first order linear differential equation. I find the integrating factor and I solve this one. We have reduced our second order differential equation. This equation given to us to the form that is here is the first order differential equation, and we can solve it. And if it is not reduced to this one, then we are not able to solve that one. Now we can just see, I find the integrating factor. My integrating factor will be, here this integrated factor is mu is equal to e to power integral 4 upon x dx is equal to e to power integral dx upon x. We take 4 outside, and we get here this equal to e 4 ln of x, and that give me here e to power ln of x to power 4. In ln are cancelled, we get here x to power 4. So I can write my solution. My solution will be d by dx x to power 4, that is my integrated factor, into w, and here also x to power 4 into 6x. That gives me 6x to power 5. Now I can solve this one, integrating both the side. I get here x to power 4, w is equal to integral 6x to power 5 dx is equal to a constant c. So I just solve this one. What I'll get? I get here x to power 4 w is equal to, get here x to power 6 or 6 is cancelled. We get here x to power 6 plus constant c, we take as a constant. Now I'll get here value of w divided by x to power 4. We get here w is equal to power x to power 2 c over x to power 4. So this is my value of w. Now I can just see I have the w. What's my w? My w is du by dx. Again, I'll get another first order linear differential equation. I get here du by dx, put the value of w, is x to power 2 plus c over x to power 4. I separate the variable. Du is equal to x square plus c x to power 4 into dx. Integrate. We get here u is equal to x to power 3 over 3 plus this x to power 4. I can write here this is c is constant, x to power minus 4 into dx. I can write here this is equal to u is equal to x to power 3 over 3 plus c x to power minus 3 over minus 3. So my u is equal to x to power 3 over 3 minus c over 3 x to power 3. So this is my u. Now I want to find my solution. What's my solution is y2 is equal to c u x square. So I get here my y2. My y2 is equal to u x square, multiply by x square. I get here x to power 5 over 3 minus c over 3x. So this is my y2. So I can see if I want to find the general solution. So plus we're having here, this is where I say here c1 and plus here c1 and then multiply by x square, we get here c1 x square. So I can rewrite my solution as my solution y. I have two arbitrary constants. I write like this one is y is equal to c1 x square. I put here this as c minus c over 3 as c2. My c2 into 1 upon x plus x to power 5 over 3. So this is my solution. So what's my c2? I've taken here my c2 is a constant that is equal to minus c over 3. So that's the idea. I will get a general solution. My y, this is y is equal to, and I say my general solution y is equal to c1 y1 plus c2 y2, and plus we having, due to this term that was our non-homogeneous term, we get additional term here plus x to power 5 over 3. We can note this one. When we are having the non-homogeneous differential equation, then we having the solution like this. This we say here y is equal to c1 y1 plus c2 y2 plus yp. Actually, we write these values which we have written here. We say this is our yc. We can write here y is equal to yc, the homogeneous part, plus yp, the additional value due to the non-homogeneous part. So that's my solution. I just repeat it for you, and we can have the more idea. This is a particular example. Here we're having non-homogeneous differential equation. First one we're having the homogeneous differential equation, but the method is same. We take y is equal to u1 y1. I substitute in my differential equation. At the end, I'll get here this equation. This x to the power 4 d2 by dx square. d2u by 4x cubed du by dx equals 6x to the power 3. Then we make the substitution. Du by dx is equal to w and d2u by dx is dw by dx. I get first order linear differential equation. It's my first order. Is first order linear differential equation. Linear differential. We know that to solve this one, we use integrating factor. Our integrating factor is this is my p of x. This is my p of x. So e to the power p of x dx. We integrate it. We get here our integrating factor is equal to x to the power 4. We write the solution. Solution is d by dx integrated factor into w. This into w and integrated factor into r of x. Here is 6x. We multiply, we get 6x to the power 5. We integrate both the sides, we get x to the power 4w is equal to 6x to the power 5 dx plus c. So integrate that one. We'll get the solution of this one as w is equal to, here we were having here, sorry for that. We missed, I just cleaned that on something here. So I just divide by x to the power 4, I get w is equal to x squared plus c x to the power 4. And we can write here this is x to the power 2 plus c x to the power minus 4. And then we integrate again, and we can have here minus x to the power 3 or minus 3. And this value, we say this is, or u, multiplied by x squared, we'll get here this as x to the power 5 over 3. So multiply x squared, we get c upon 3x. Multiply x squared, we get this one. So this is my also general solution. This is my y2. y2 I will say here, if I take y2, and this is my y2. My y2 is equal to 1 upon x, because here we were using find the general solution, not the y2, because it was a non-homogeneous differential equation. Our general solution, they're multiplied by x squared, y is equal to c1 x squared plus c2. I take this c2, I just substitute this constant is equal to minus c over 3 as a constant, c2, and then plus x5 over 3, multiply by, taken here, x5 over 3. Now we can have here, we written here the solution y equal to c1 x squared plus c2 1 upon x plus x squared 5 by p. I explained this one, that y is equal to c1 y1, this is my y1, plus c2 y2, this is my y2, plus this one we say yp, particular solution. So when you take only the homogeneous part, we want to take the solution for this equation here, and this one, then we're having y1 y1, c1 y1 and c2 y2. But due to, and that was this was yc, and due to this value we're having on the right hand side 6x to the power 5, we get the additional term x5 by 3, and we say the particular solution. Inshallah, we are going to discuss this one in later stage a lot. We are having the equation which are non-homogeneous, and we want to find the solution. They will find yc and yp. So again, before going further, I would like that you must, you'll get the notes of this lecture in the description. You just click it, go down, and you can download the notes. There are many examples, especially in this section. You can just make practice by taking these examples. So best practice to best utilization is you solve your problem, and then you compare your result with the result given in the notes. And if it's not correct, try again. Yeah, you must make the practice. And there are many other exercises given in the notes. You can you can use that one. Also, don't forget to subscribe the channel.